There are a couple of ways of solving this question. It is possible to figure out this length here using Pythagoras, and then figure out that angle there using the cosine rule, and then use the sine rule to multiply those two together to find out the area of that triangle. Some people did that. That works fine. Far easier is to think all we need. If we knew that length there, then it'd be really easy to work out the area of this triangle, and this triangle, and this triangle. So that's the way I'm going to do it. You can use the sine cosine rule way if you want. But I'm going to find this one. Now, just before I start, it's a show that question. It gives me the answer, and I've got to present my work in a way that will make it fine. So first, I'm going to find the length of DC. So I need to make sure that everyone knows what I'm doing. So I'm going to write DC squared plus 2 squared is equal to my hypotenuse squared. Okay, so DC squared plus 4 is well, I need to square the 2, which is 4, square root 10, which square root is just undoing it, so that's 40. So DC squared is 36, so DC must be 6. No need to positive or negative here, because I know it's a positive length. Wow, away, sorted. If I know that's 6, what else can I work out? That's going to be 4. I already know AD is 4 because it's a rectangle, the opposite side will be the same. So I'm going to figure out each one. Each of these 3 triangles bit by bit. Just because my screen's small, I'm going to do it over here, but I'm going to do it in a different colour. I would do this underneath normally. So triangle DCF, I guess. I can label those in any order. So the area of that is going to be 6 times 2 over 2, which is 6 centimetres squared. Triangle EFB, that bottom right, EFB is 2 times 2 over 2, which is 2, so that's fine to say. On the left here, triangle ATE is 4 times 4 over 2, 16 over 2 is 8 centimetres squared. So now I've worked out the area of all 3 of those. The quadrilateral, so the whole quadrilateral, which would be A, B, C, D. I don't think this is actual notation, but you know what, you shouldn't worry too much about that either when you're at exam. So the area of the whole thing will be 4 times 6, come on brain, near the end of the paper, so you start getting tired, which is near the end of the paper, you start getting tired. So 24 centimetres squared. So to find my triangle, what's the triangle I'm after? DEF. Triangle DEF. It doesn't take long writing these in, but it helps so much with making sure you get your marks. It's going to be 24. Take away. First triangle. Second triangle. Third triangle, I hope that's 8. One of the nice things about these questions is you know you're right or wrong straight away. So, 8 centimetres squared. No space for an answer box, because it's already given me the answer. I'm just going to double underline it just so they know. Oh, look, that's right there, that's the answer. So, the show that question, your presentation is key. You could have done all that without writing the triangles and just in one big row. If you make a mistake, you're less likely to get all the marks. It's much, much better to write down what you're doing each time. Use correct labels. I mean, I used DC. You could have written an X up on there and done it, but make sure you're using some kind of obvious notation so that the examiner knows what you're doing.